All right, everybody, welcome back. This is the third and final video on Section 3 from Unit 4 of AP Calculus, Rates of Change in Applied Contexts Other Than Motion. And we have two more examples that we did not get to in the first two videos, so we're going to go ahead and go through those two examples here, and then we will call it a day. Example 7, which comes from the 2019 AP Calculus exam. It was free response number 1, which means it's a calculator problem. Fish enter a lake at a rate modeled by. So this is the rate of entry is our function e. So that is already the derivative, so to speak, of the total amount of fish entering the lake. Fish leave the lake at a rate, again, leave at a rate modeled by the function L, which is this function. Both E of t and L of t are measured in fish per hour, and t is measured in hours since midnight. So the rate at which the number of fish is changing, rate of change of number of fish, is equal to the rate at which they enter minus the rate at which they leave, E of t minus L of t. Now, question D here, which we're answering, is the rate of change in the number of fish in the lake increasing or decreasing at 5 a.m.? Explain your reasoning. So when we're talking about whether the rate of change is increasing or decreasing, we're actually talking about the rate of change of the rate of change. So we want the value of the derivative of this function at time 5. Okay, now the derivative of this function is e prime of t minus L prime of t. And so at time 5, we're looking for e prime of 5 minus L prime of 5. I'm going to go ahead and use my handy dandy calculator to find that value for us. So we are going to take, if I can ever turn my calculator on, there we go. We are going to take the numerical derivative of 20 plus 15 sine of pi x over 6, close the sign, with respect to x at 5, minus the derivative, and again I can just use the n deriv, minus n deriv of 4 plus 2 to the, missed my plus sign, 4 plus 2 to the 0.1 x squared with respect to x, again at time 5. And we punch that up, and it gives us this value, which is negative 10.723. If we truncate, we can have negative 10.722, so that's also acceptable. 722 also acceptable. And so the rate of change of the number of fish in the number of fish is decreasing. Because e prime of 5 minus L prime of 5, the rate of change in the number of fish, I probably should have written at 5 a.m., is decreasing because e prime of 5 minus L prime of 5 is negative. All right. And example 8. From the 2003 AP Calculus exam Form B, free response number 2. A tank contains 125 gallons of heating oil at time t equals 0. During the time interval from 0 to 12 hours, heating oil is pumped into the tank at the rate h of t equals blah, blah, blah. During the same interval, heating oil is removed from the tank at the rate r of t equals blah, blah, blah. Is the level of heating oil in the tank rising or falling at time t equals 6 hours? Give a reason for your answer. So, if we want the level of heating oil in the tank, that's the total amount of heating oil. And so these rate functions that we have, we were told that this is a rate function, rate at which heating oil is pumped in, rate at which heating oil is removed. Okay, so if the rates, the difference of these two rates is positive, then it's going to be rising, and if the difference between the two rates is negative, it's going to be falling. And so we want to just find h of 6 minus r of 6. And that's going to give the rate at which heating oil is changing in the tank. And so I'm just going to go ahead and take 2 plus 10 over the quantity 1 plus natural log of, and we're doing it at time 6, 6 plus 1, close that, close the denominator, minus the rate at which it's exiting, 12 sine of 6 squared over 47. That gives us negative 2.924, whether we round or truncate. Negative 2.924 gallons per hour. And so the level of heating oil is falling because the rate at which heating oil is removed is greater than the rate at which heating oil is pumped into the tank. And there we go. That's our last example. That's going to end it for this section. Come on back next time, and we'll see you for more calculus fun. Have a great rest of your day, everybody.